Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll show you the derivative, the proof for the derivative of logarithmic functions. Of course, you know that a logarithmic function is any function involving logarithms. And if you do not know, you can check out my basic calculus series of videos. I have a whole playlist for that, about 26 videos there. So check it out, and you'll find you can start from the first video where I talked about functions. So you get more understanding about logarithmic functions. So if you have a logarithmic function, of course, here the logarithm is the natural logarithm ln. So if you have to differentiate y equals ln f of x, the derivative is simply this: dy dx equals f prime of x over f of x. So you see f of x here, you differentiate it, that's f prime of x, and then you divide it by f of x. And that is the result whenever you differentiate a logarithmic function. So the proof of this is what I'm going to show next. So let's see that right here. Okay, you have y equals ln f of x. Y equals ln f of x. So because of this ln, right? The way to, if you remember the idea of inverses of functions, right? The inverse of ln is exponent. So you take the exponent of both sides, e raised power y, e raised power ln f of x. So the reason why we're doing that is because we know that e ln f of x will end up giving you f of x on its own like that. So that's a way to remove the ln. So you have e raised power y equals f of x by the time you take the exponent of both sides. And then the derivative you're looking for will amount to taking d dx of both sides, d dx of both sides. But you'll already see that to take d dx of e raised power y does not look realistic. So what we can do to take care of that is to break down this d dx. You know, you can break down d dx into d dy of whatever multiplied by dy dx such that dy still cancel out, so you have your d dx intact. So that's a way to do that. It's more like a chain rule of function of a function, right? So you have d dy of e raised power y, and then you have to balance that up, you have dy dx multiplying that, so you still have your d dx. Okay, and on the right hand side, it's straightforward. You have d dx of f of x. And so here, if you differentiate e raised power y, you keep getting e raised power y, right? If you do that 1,000,000 times, you always get e raised power y. Maybe I'll do the proof for that, why the derivative of e raised power y is always e raised power y. Okay, so of course, and the dy dx is there. So d dy of e raised power y is e raised power y multiplied by dy dx. And on the right hand side, this is just f prime of x. And since our focus is on dy dx, so you have to divide both sides or multiply both sides by e raised power y, multiply both sides by by 1 over e raised power y, that is. So e raised power y cancels this out. So you have f prime of x times 1 over e raised power y, which is the same thing as f prime of x divided by e raised power y as we have it here. So, and you remember that e raised power y, if you go back, e raised power y is f of x. So that means that dy dx is simply f prime of x divided by f of x, and which settles that proof that whenever you have y equals ln f of x, y prime or dy dx is the same thing as f prime of x all over f of x. Thank you so much for listening. If you have not subscribed, be sure to do that, so that you can, and also press the notification bell so you can always get alerted whenever a new video is released. See you in the next video.